Alright, today we're going to be talking about the volume of prisms and cylinders. Remember that in volume you're going to have units cubed. So if I were to fill a graduated cylinder, let's say that it was in units of milliliters, whatever number I read on the side of my graduated cylinder would be milliliters cubed. Okay? That's because volume is length times width times height in a rectangular prism. Alright. Before we get too far, what I would like to do is there's a couple of different applets that you can use to observe what we call Cavalieri's principle. So we're actually going to look at this bottom one, but I've left the top one up here for you in case you want to check it out on your own time. Alright, so what you see here is this applet. Now, I have a cylinder here with a height of 14 and a radius of 12. I can actually change the radius, I can change the height, and make different volumes. So what I'm going to do is I'm going to make this, let's say, 13, and then let's see if I can get this to be 10. There we go. So the volume of a cylinder is going to be pi times the radius squared times the height. Now that makes sense because I have a circular bottom, so I find the area of the circle, which is pi r squared, and multiply it by 13. That's because I could fill this up with these different circles laying on top of each other. Now what's really cool about Cavalieri's principle says is that no matter, let's imagine this is a stack of CDs. If I take my stack of CDs and this time stretch it to the side, kind of like a slinky or a stack of CDs if you slide it, notice that the volume did not change. So I'll move it back. Here it is, straight up, a right cylinder, and you'll see that the volume is 4,084.1 units squared, or units cubed. However, if I take that same cylinder and slide it, it's still the same volume no matter where I go. Okay? So let's try it again. Let's do something else. Let's make it a little bit taller and real skinny. How about that? Right. There's 3. Okay? So I'm going to freeze the height, and then I'm going to change it so that it, look at that, 500.5 units cubed no matter how I tilt this. That's what we call Cavalieri's principle. Just because I have an object, a cylinder shape, or even a cone, or a rectangular prism, just because I tilt it, kind of like the Leaning Tower of Pisa, right? The building originally looked like this, and then over time went kind of tilted. The volume of that shape is still going to be the same regardless of how it's tilted. So what you see here is a more formal definition of Cavalieri's principle and of the definition of volume. So Cavalieri's principle says that if two three-dimensional figures have the same height and have the same cross-sectional area, what that means is if I were to take a plane and slice the object in the same, if the base are the same size at every single level, meaning if I were to cut at the bottom, the middle, the top, somewhere in between, all over, it's going to have the same volume. So the right prism that you see here and this oblique prism that you see here have the same base and the same height, therefore they have the same volume. Alright, so what we have here is some formulas that we need to discuss. The first and foremost is the volume of a prism. The volume of a prism is the area of the base times the height. This is the formula that you're going to see, V equals capital B times H. You need to realize that when I say capital B, that I mean the area of the base, not just the length of the base, but the actual area. So in this prism, there's a triangular base, and I must find the area by 1/2 base times height, and then multiply it by height to get the volume. Okay, this what you see here is on the formula sheet. These are not on the formula sheet. So the volume for a rectangular prism is still going to say capital B times H on your formula sheet, but in this case the base is actually a rectangle, which we know to be length times width. So it's just length times width times height rather than capital B times height. But you're going to see it this way on the formula sheet, not this way here. And then because a cube has all the same sides, it's just side times side times side, which is side cubed. Alright, so for an example, let's go ahead and find the volume of this rectangular prism. Round to the nearest tenth if necessary. So what we have here is a base length of 13 a width of 3, and a height of 5. So this is going to be 13 times 3 times 5, which is 195 centimeters cubed. Alright, find the volume of a cube with the edge length of 15 inches, round to the nearest inch or tenth of an inch if necessary. Now, we know that a cube has all the sides the same, so it would be 15 times 15 times 15, or 15 cubed, which is 3,375 inches cubed. Alright, so it says find the volume of a triangular prism with a height of 9 yards whose base is a right triangle with the legs 7 and 5 yards long. So I have a right triangle, 5 and 7, and that's my right angle here. So what I have is I can find the area of this triangle pretty easily. Its area equals 1/2 base times height. So the area of this triangle is 1/2 times 5 times 7, which is 17.5 yards squared. Now, if I were to take this triangle and build upon it, excuse me. Okay, this triangle multiplied by the height of 9 yards. So I would take this 17.5 yards squared, let's put 17.5. And I multiply it by 9, that's going to give me the volume of 157.5 yards cubed. And that is the volume of the triangular prism. You had to find the area of the base first. And the base was a triangle, so I used the area of a triangle formula, 1/2 base times height. And then I had to multiply it by the height of the prism in order to get the volume. Alright, here in this picture we have a hexagonal prism. What that means is the base is actually a hexagon. Do you remember in our previous video we were asked to find the area of regular polygons? Well, in order to find the volume of this hexagonal prism, we must first find the area of the base, the hexagon. So we have to do exactly what we did yesterday. We have a right triangle inside here. Let's see. Okay, here's the apothem, and then the side length would be 4.5. So I'm going to take this and draw this triangle out a little bit. 4.5, A, and then, excuse me. Try this again. Right angle, 4.5, A. The interior angle of this triangle is going to have to be 360 divided by 6, and then divide that by 2 again. So this will give me a 30-degree angle right here. Alright, so using tangent, we can say that the tangent of 30 equals 4.5 over A. 4.5 over tangent of 30 gives me the apothem, which is 7.8 feet. Now the perimeter is 9 feet. There are 6 sides, so the perimeter would be 9 times 6, or 54 feet. So the area of the base equals 1/2 times the apothem times the perimeter equals 210.6 feet squared. Now that's just the area of the base of the hexagon on the bottom of this shape. Now all we have to do is take this number and multiply it by the height. How tall does the prism go? So 12 feet is how high, so the volume will be 210.6 times 12 feet high, which is 2,527.2 feet cubed. Alright, so what we have here is, again, just a refresher of Cavaliere's principle. Here's a stack of CDs, and here's a stack of CDs if I had leaned them, made them an oblique cylinder. So the formula for the area is still the same. It's the area of the base, or the area of the circle, times the height. Now, because a cylinder has the base of a circle, we would use the formula for area of a circle, pi r squared. Okay, so some good examples of Cavaliere's principle could be like the Leaning Tower of Pisa, a stack of CDs, You know that cranberry sauce you have at Thanksgiving when you take it out of the can, it kind of leans a little to the side? It's still got the same volume, right? Well, those are all great examples of Cavalieri's principle. So let's put that into play. Here is an oblique cylinder, and I need to find the volume of it. In order to find the volume, all I need to do is find the area of the base first. Now, area equals pi r squared because this is a circle. But you'll notice I've been given the diameter, so I need to divide 18 by 2 to get the radius of 9. So that would mean that the area of the circle is 81 pi. Now, I'm going to leave it in terms of pi because I want to round at the very end. Now, the volume of the cylinder would be that 81 pi area of the base times the height 14, which would give me 1,034 pi inches cubed, or if I round, 3,562.6 inches cubed. Alright, in this case, we're asked to find the volume of a cylinder that already has the base area of 121 pi, and the height that's twice the radius. So what I need to do is, this is the formula for the area of the circle. Area equals pi r squared. So I would need to figure out what r is if the area is 121 pi. Oops, I forgot the pi there. Let me write that again. 121 pi equals pi r squared. So when I divide both sides by 5, I get 121 equals r squared. Square rooting both sides, I get r equals 11. That means that the height has to be 22 because it's twice the length of the radius. So taking this information, I can now go back and say, okay, the base was 121 pi, and now I know the height to be 22 centimeters, so that means the volume must be 2,662 pi centimeters cubed, which is approximately 8,362.9 centimeters cubed. So we had to go back and find what the radius was, multiply it by 2 to find the height, and then once I had the height, all I had to do was take the base they gave me in the problem, the area of the base, and multiply it by 22, my height. Now, Cavalieri's principle doesn't only apply to cylinders. In this case, we had a rectangular prism that we have then stretched to the right-hand side. So it's not really rectangular anymore. It's probably more of a parallelogram of prism. I don't even know if that's a word. Okay, so the volume would simply be 1.5 times 4 times 3. So that would be 18 feet cubed. However, that's not quite what the problem is asking for. It says if the length, width, and height of the prism shown are doubled, describe the effect on the volume. So let's go ahead and mark out all of these, and let's say this is 3, this would be 8, and instead of 3, this would be 6. So the new volume is 3 times 8 times 6, which is 144 feet. Yes, volume equals 144 feet cubed. So what is the difference from 18 to 144? So all I would do is do 144 over 18, and I see that it's 8 times bigger. And that actually makes sense, because if I multiply each side by 2, I multiplied by 2, multiplied by 2, multiplied by 2, 2 times 2 times 2 is actually going to give us 8. So that means it's 8 times bigger. Does that make sense? Alright, here is a composite figure, meaning that there are multiple shapes inside of each other. First, you have a larger cylinder with an inside cylinder cut out of it. So I want you to find the volume of this composite figure. Pause and give it a shot. I'll give you a hint. You need to subtract the two volumes. Alright, so what you see here in blue is the volume of the larger cylinder, and then what you see in red is the volume of the smaller cylinder. In black, you'll see where I have subtracted the two volumes, and I've got 2,916 pi inches cubed, and then if I were to round it to the nearest tenth as the direction says, it would be 9,160.9 inches cubed. Alright, well that's it for today. Our next video will be over pyramids and cones. See you then.